All right, let's take a look at question 7. Now, this one here is from the Theta Mathematics 18.05. We'll look at 7i. So the first few here are all based upon the idea that if you have the same base and you're multiplying or dividing, you can simply add or subtract the powers. So let me just give you an example of that. So let's take a, for example. So I've got x to the n plus 1 times x to the n minus 2. So here we go. Let's do that one first. X to the n minus 1. I'm going to multiply it by x to the n minus 2. So there we are. That's what we've got. Now let's go ahead and simplify this. So to simplify, all we're going to do, because we see the bases are already the same, we can just go ahead and add the powers together. So let's go ahead and do that. So we're going to end up with an x. This is going to be n minus 1. There's going to be a plus and an n minus 2. So what have we got? We've got x to the, well, I've got an n and an n, and well, n plus n is 2n. I've got a negative 1 and a negative 2. Well, negative 1 minus 2 is minus 3. So the answer is going to be x to the 2n minus 3. Let's try another one. Let's have a look what we've got here. I'll choose C. So I've got x to the 3n. I'll just write this out over here so you can see what it is. So I've got x to the 3n times x to the 2n, all divided by x to the 4n. Well, we've got a common base. We've got an x. So here I've got these two multiplied by each other, so the bases are the same, so I can add the power. So that's going to be 3n plus 2n. And I'm dividing it by this thing here, but the base is still the same, so I can just subtract the 4n. So I end up with an x. Now I've got a 3 and a 2 is a 5n. I'll write it out so you can see it. 5n minus 4n. And of course, 5n minus 4n is just going to be n. So there's going to be my solution. All right, now let's have a look at number I. Here we go. So this is 7i. Now, same principle applies. Same principle applies. Let's have a look at that and see where we end up. So we've got, so I was going to make sure I'm writing down the right one here. So I've got x to the 2/5 over, sorry, it's not out of focus a bit, sorry about that, x to the 1/3 times x to the 1/5. All right. Now you can break this up and do it in any way you want. I'm just going to simply add and subtract all the powers in the order they occur. So the first one is I've got all the bases are x, so I'll put an x here. I've got a 2/5. Nothing to add this to, but I'm going to subtract 1/3. And I'm going to subtract 1/5. Now, of course, if you're good with fractions, you can just go ahead and add and subtract those as necessary. I'm going to cheat, and I'm going to use a calculator. So I'm going to say, well, we've got, let's have a look, we've got 2/5. We've got minus 1/3 minus 1/5. Let's see what we get. And we get negative 2/15. So the answer is going to be x to the power of negative 2/15. And there's our solution. Another way you could have done that, if you felt so inclined, is added the bottom ones first and then subtracted the answer from the top. So it would look something like this. I'll restate the problem. So it's going to be x to the 2/5 over x to the 1/3 times x to the 1/5. And that's going to equal, and I'll just write this out again, so it's going to be x to the 2/5 over x, I'm going to keep the base the same now, and I'm going to add these two together. I've got a third and a fifth. Again, I'm just going to use a calculator. So 1/3, here it is, 1/3 plus 1/5, and I end up with 8/15. So I've got to the power of 8/15. Now I'm going to subtract these two, so I'm going to go equals x, and this is really 2/5 minus 8/15. So where do I land? Let's see. X, and I'm going to say 2/5 minus 8/15. 2/5 minus 8/15. There it is. And I get negative 2/15. So it's going to be x to the power of negative 2/15. And there is my answer. Same answer as before, and that's a good indication that we're on the right track.